Hey, here we are. It's our last thing in our little boot camp. Hope you made it this far. We're going to build a little lottery picker game. And it's pretty cool. It's fun. It goes over everything that we talked about, except I didn't put it in a class. You can, if you want to venture out and build it in a class, please, by all means, do so. Build it in write this thing out in a class. And what are we going to do? We're going to build this. It's going to ask us a question. It's going to say, how many numbers would you like? And I thought, well, with the Powerball being $100 million, I sure would like to have a piece of that. So I'm going to get 5. And then it's going to spit out my Powerball numbers. So now you notice I have 5 numbers, and then I have a Powerball. So I don't know if any of these are winners. Trying to get like $8 out of me is rough. I'm cheap, so I don't really play the Powerball. But let's look at how we built this application. And really, it's all the stuff that we've talked about. I didn't put it in a class. I said that earlier. And there's two things that I added to it. So this is all that it is. It's a simple little 50-line piece of code. And here's our main. We talked about our main. This is where we're going to run our program from, right? So let's go over our basic starts, our includes. Now we know we have include IOStream that kind of starts when we start. We've already talked about including a vector. So we're going to include vector, and that means we're going to use a vector or a container to store our lottery numbers. And then we're going to use this thing called include algorithm. An algorithm allows us to apply different methods onto the vector class. Because if you ever play the lottery numbers are always from least to largest. So they're not jumbled up, they're always ordered. So they're always sorted from least to largest. And we can do that with an algorithm that's going to allow us to do that, and a method called sort. And that lives in the algorithm class. And then we're going to do a thing called ctime. Ctime is really important because you're going to need random. You're going to need to be able to build random numbers. Ctime allows us to build random numbers. And we'll talk about how ctime does that right now. Let's go down here. So ctime comes in and it says, okay, you now have complete access to a lot of the time library that we use, and that also gives us access to the processor clock speed. And then what we do is we have a method. We can't use srand because we can't use srand if we don't include ctime. You'll get an error. So srand means pseudo random. So this is, I want to find a pseudo random number. And what am I going to make my seed? Meaning, how am I going to generate this random number to be random? Well, what I'm going to do is I'm going to call the time, and I'm going to set the time to null. So right when I run this, it's going to grab wherever that clock speed is and just make that my random number generator. So now I have this huge decimal number. And then I'll show you how to turn it into an actual random number. Here we know how to declare a variable. I declared an integer called times. Then I asked the user a question, how many numbers would you like? Now this is a new thing for us. We have cout, right? Out. And that means output to the screen. Well, cin is another stream up. These are stream operators. It says cin says, okay, I want you to take user input. I want you to store it in the variable called times. And if it's not an integer, give me an error. Okay, we don't throw a lot of error checking on these quick codes. So I created time as an integer variable. Now I'm going to let the user add a integer into the variable. So now we have user input, and that's awesome. Then I'm going to run this for loop, and it's going to run as many times as the user tells it to run, right? It's just going to run as many times as the user tells it to run. So let's say, oh, I would like 10 numbers, right? 10. I hit enter, and now I have 10 numbers. So I have 10 different potential lottery winning numbers. And we're just going to run one method called getNum. So we run this method called getNum. Now let's go look at our methods. Here's my getNumbers method. See? Void getNums. This doesn't return anything because we just want to print out values. What did I do here? I declared a vector for my numbers, and I called the vector my riches. Now, if we look at what's going on here, for I is 0, I is less than 5, I plus plus. That's going to build 5 random numbers. And I'm just going to push those into my vector. Remember, we have pushback. And how does it get the numbers? Well, we created srand, pseudo-random number, and that makes our seed. And then we're going to call the random method. And what we're going to do is mod it by 69. So that'll give us random numbers. Remember, if we mod something, it's 0 up to but not including the number we're modding, because it returns the remainder. So either it's divisible by 69 or it's not divisible up to 68. Now I add 1 to that. What does that do? That shifts it, so it's not 0 to 68. That shifts it to 1 to 69. If you look at the rules for lottery, the first 5 numbers are in a range from 1 to 69. We've just done that. So what else do we do? Now we need to sort those numbers. So we use the sort method that comes inside the algorithms library. And what are we sorting? We're going to sort my riches. Where are we going to start sorting from? Well, remember, vector's a library, so libraries come with a lot of methods. So my riches, I want to start at the beginning and I want to sort all the way to the end. Now, this uses a quick sort. We can talk about that in another class. But just know that if I have a bunch of numbers, they're sorted. What's another rule for the lottery? No duplicate numbers. So let's do a little thing. How are we going to find duplicate numbers? Well, if you have sorted numbers, where are the duplicates going to be? They're going to be next to each other, right? If I have 2 5s and I sort it and it's 2, 3, 5, 5, 8, 5 is going to have to be next to each other. So what am I doing? I'm going to loop through, and notice I don't go through the whole vector. I stop 1 to the end because I'm going to compare 0 and then 0 plus 1. So if the number at 0 is the same as the number at index 1, I want to replace the number. That's it. I'm just going to replace the number. And it just goes and checks the first index, second index, third index, and fourth index. It just checks its neighbor because the neighbor is going to have to be a duplicate. If there's any duplicates and it's sorted, the neighbor will be a duplicate. So I'm just going to go ahead and replace it. Right? Now, not the most perfect of algorithms, but we'll get there. And then what do? I now have my lottery numbers. 5 numbers that are in the range from 1 to 69, sorted, ascended, with no duplicates. Then I have to pick my, what do I pick? I have to pick my my Powerball. So what do? Powerball rule is 1 to 27, and it's always at the very end. That's why we don't put this in first, because it would get sorted. So now we're just going to push back because we can just add to the end of our vector, and we're going to push back a new Powerball number. Then we're going to call the method show my riches. And here's show. Show we did a bunch of times, right? We're just going to print it out. So what are we going to do? We passed in vector, right? Because we passed in my riches. So then show says, okay, here's my riches. And it prints out the first 5 numbers. Remember size minus 1? Because we have 6 numbers now because we added the Powerball. So it prints out the first 5 numbers that are sorted. And then it leaves the loop. And then it prints Powerball and then the very last number, which is 5. Every time we run this, we're not storing anything. We just print it out, 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 print it out. The vector is only used once, but it displays as many times as we want. And that's our abstraction. Okay? So what we'll do is pause your video when you get a second. Go ahead, type this up in the main. Come up here, make sure you get these included. Do this method, right? Includes namespace standards so your cout doesn't get goofy. Include this method. Sorry, I didn't mean to hide it. Include this method. And then run this method. Type this method in. And then get it to run and play with it. And see what you can do to change it. Make it better. Do a different game. Build a guessing game. Some fun things. Play this. Go and win $800 million. That'd be cool. But go ahead and just play this and go through it and see what you can do to make it change. Play with randomness. Do all these neat things. You're going to be great. We'll get my email out at the end of this somehow, and you guys can email me with any questions. I'd be more than happy to answer any questions. You can just email me at, let's get my email up here really quick. It would be, let's go M Sarlo. M is in Mike. Sarlo, S-A-R-L-O. So M Sarlo at dallascollege.edu. All right. Any questions? You just go ahead and email me. We'll work through it. All right. If anybody needs anything, please email me if you want to expand on some of these concepts. You did a great job if you got to the end of this. I think you're making the right choice with Dallas College, and I think you're making the right choice, either computer science or software development or engineering. That's just a wonderful field to be in. Okay, if you need me, reach out. Bye.